I'm probably not going to introduce these people because I think they would probably do a better job introducing themselves. But I'm just going to give an introduction, and then I'll let everybody introduce themselves because they could probably tell you all the awesome stuff they're doing better than I can. I want to thank Dennis for inviting me out here. He contacted me, and he told me that he thought, the stuff I was working on was really cool. It was really similar to the stuff that happened with the Homebrew Computer Club, except with biology. So I'm one of those people who kind of calls myself a biohacker. Now, it comes from the hacker term, not, the black hat nefarious type of hacker, but more the original usage of the word where somebody's doing something clever and new and kind of ingenious with the technology. And biohacking is doing something clever and new and cool with biology. What happened was, I was once like all of you.
And then look what happened.
You're like, I hope not. No. So I was in academia. I did my Ph.D. in biochemistry and biophysics. And as I was going through academia and also NASA, I worked for 2 years at NASA doing genetic engineering and synthetic biology. The one thing I saw was that like all the cool things that we wanted to be people who do computer science and electrical engineering, you already get to work on the cool things, right? You're already making robots, self-driving cars, artificial intelligences, and things like that. Really awesome. That's what everybody wants. In biology, what we want is like, dragons. We want humans with prehensile tails and stuff like that. And instead, I spent my PhD studying the biophysical mechanisms of light activation in the avena sativa light oxygen voltage protein. Exactly. That's what I'm saying. What is that? What happened? And so it kind of inspired me, and I started thinking, well, there's all these things that people want to do, but you can't get the grants to do it, or it's too fringe, right? You can imagine somebody saying, I want to make a dragon, and people would just be like, you're ridiculous, you're crazy, get out of here. But we're starting to get to the place with this biological technology where we can edit genomes really easy of all types of organisms. And we can start making things with that, right? It's really impressive and awesome what's going on right now. And so I started to get in, well, how can I take this to like a hobbyist level, right? You got these big labs where you're doing these experiments, kind of like the days when, the only people who had computers were labs and universities and big companies. And then it started to move slowly away from that. You started to get the hobbyists involved. And that's what's happening now, And I started building a lab in my apartment. And then other people, I wasn't the one who initiated this, but then a lot of other people are building labs in their apartments, and it's starting to grow and grow and grow. People are engineering organisms in their apartments for little or no money. People are using equipment that was once thousands and hundreds of thousands of dollars, now getting it used or building it themselves for hundreds of dollars, right? And it's this change of the digital, right? The digital is always going to be there, and it's computers allowed us crazy access to this digital world where we can do stuff. But now, the biological, right? You can take a seed, and from that seed, you can grow a massive tree, right? And it gets its carbon from carbon dioxide and elements from the soil, right? Like that tree grew from carbon dioxide and the soil. That kind of blows my mind. So how can we use that, though? How can we use that, right? And, even when I was in synthetic biology in academia, but especially now, being in the Bay Area and Silicon Valley, people like to make these claims like cells are computers and DNA is a programming language, right? But they're not, right? People have tried, there's been papers published where people are like, let's make and OR gates in cells. And then like 2 hours later, they're able to do one single computation, right? You're like, what is that going to compete with? Like, come on. In programming DNA, no matter how hard people try to make DNA a programming language, it's not an exact thing, right? It's a dynamic system. There's so many different things going on. DNA does make proteins, but there's all these other things that affect it, right? The post-translational modification of these proteins, misacylation of these proteins. Like, the temperature, the thermodynamics of the system that's involved, the sodium, all these different things in there that allow proteins to fold and interact with other things. And it's like, why are we trying to make it a programming language? And why are we not just seeing the things it's good for and learning how to access that, right? Organisms, growing things, building things, and things like that. Anyway, that's my little rant about what the talk's going to be about today. You heard a little bit about me, so why don't you all introduce yourselves and let us know a little bit about you.
Sure, I'll start. Thanks everybody for having us. I'm Moe Islam. I'm a venture capitalist at DFJ. We have an early stage and growth stage tech fund and life sciences fund investing in kind of the intersection of information technology and biotechnology. So investors in companies like synthetic genomics, Human Longevity Inc., which the name is kind of in there of what they're trying to do. But then also companies like Atomwise and Zymergen that are doing everything from machine learning applied to drug discovery to optimizing microbes to produce things like flavors, fragrances, things like that. So really interested in how we can use technology to kind of unlock the power of biology. You know, I think similar to Josiah, I think that the analogy that a lot of people have been using, especially a lot of tech investors, are guilty of this because we're starting to put money into these life science companies without really understanding what we're doing. But you know, a lot of that is happening right now in the Valley, and I like to think we're smarter about that. But you know, every VC has its bad portfolio. Right? Yeah, exactly. We only get 1 out of 10, so you just got to get that one. But you know, with kind of the advent of the cost of sequencing coming down, you know, faster than even Moore's law would predict in terms of computational power, you know, to this multimodal generation of data that we have now with DNA, RNA, where we can do things like map genomic data to phenotypic data, understand disease states. It's kind of phenomenal from my perspective as an investor, just what we're seeing in the market now with all of these companies getting started and a lot of capital flowing into these companies. And so including some that we're going to hear about today, some of these guys are actually starting companies. I'm just the investor, but really excited about what we're seeing in the market. You know, I don't think cells have to be computers. I don't think DNA has to be a programming language, but I think we can still leverage those and use technology advances in computation in hardware with costs coming down and kind of leverage the power of biology. So that's what I'm really excited about.
Great. Yeah, so my name is Hannu Rajaniemi. To get sort of the embarrassing thing out of the way, I am a science fiction author. And you may know me as the author of books like The Quantum Thief. But I do have an academic background as a theoretical physicist. I did my Ph.D. in string theory, which is probably even worse. Started a company working on data science and AI, but then really got very excited about biology. And actually what really drew me into biology, or the sort of paper I read that really sort of made me realize that something crazy was happening, was a paper about DNA logic gates. And not because it was sort of impressive computationally, but the fact that we could engineer a very artificial system. We actually had the ability to put it into a living cell and do something. And yes, noisy, rubbish, sort of nothing like our silicon, but still, what could a system like that do if you actually put it into the body? And so I sort of started thinking about that space. And I think there is this kind of long-running fascination that people coming from mathematics and physics have with biology, going back to people like Alan Turing and John von Neumann, who sort of both worked on both things. And I think one of the first programs that the Joniac, the sort of first programmable computer that von Neumann's team built at Princeton ran, was actually an artificial life simulation back in the 50s. So this is sort of a long association. But I'm sort of definitely excited about this space because I believe that we do now have this amazing stack of tools that allows even individual hobbyists sort of do self-experiments and very, very cool experiments. And there's so much unknown about biology that even a single individual or a small team can make astonishing discoveries that have tremendous impact on human health. So I'm a co-founder of a startup called HelixNano Technologies, and we're sort of an early stage startup trying to work on new ways to actually get synthetic DNA that could do some of these exciting things into human cells. So yeah, very happy to be here and tell you about our journey with these guys.
Hi, I'm Jane Metcalfe, and I am, I think this is Bruce Sterling, who many of you may know as a fabulous cyberpunk author, called this the weirdest panel ever, which I think is really interesting, and it's a reflection of this man's mind, which is also interesting. But I think I was invited because of what I saw happening about 25 or 30 years ago and what I see happening now. So 25 years ago, this month, we launched Wired magazine. My partner, Josiah, and I had come from Amsterdam, where we were watching what was happening as all these different data types were getting digitized, and what people were then going to be doing with those data types. So we were watching, of course, first text, and then all the interesting things around how we understand text, and so that led us into sort of machine translation and all sorts of neural networks and linguistic programming and all that really cool stuff. And then, of course, digital audio, digital video, now you're editing that stuff. And then we thought, we were called this with a magazine called Electric Word. And then we thought, this is going to start to really change everything. Not only are all these data types going digital, but it's going to change the way we learn, the way we are entertained, the way we store things. It's going to change business. It's going to change politics. It's going to change our culture. It's going to change everything. So we coined the phrase digital revolution. We moved to San Francisco to launch Wired, literally 25 years ago this month, which seems like a very long time ago. One of our first employees was Kevin Kelly, who wrote a book in 1994. He actually took sabbatical from the Whole Earth catalog to publish this book, and then he took a sabbatical from his book to help us launch Wired. So that's like a sabbatical squared, or 2x or something. And his book was called Out of Control. And the subtitle on the original issue was Fast Forwarded to a Neo-Biological Civilization. And the stuff he was writing about then, first of all, the book was became a Bible in boardrooms. The chairman of the boards of all these companies were reading it, and what is the future? And Kevin Kelly shows us the future. And what they gleaned from that was, things like the collapse of hierarchical systems, the rise of, the IT person and the power that they would wield, and how quickly they were going to have to convert everything to digital, and how that would transform their businesses. But what was really interesting was the stuff he was talking about was biological. And it was so out there 25 years ago. And about 3 or 4 years ago, I picked up the book again, and all of a sudden I realized it's like, damn, this is happening now. And kind of right on schedule. And it happened as I was leaving my post as president of Choke Chocolate, which had this fabulous chocolate factory up in the Embarcadero in San Francisco, and dealing with my 3 octogenarian parents in Kentucky, so 2,500 miles away. So I started thinking about mental illness, which they were suffering from, and also Alzheimer's and dementia and neuroscience, and what is the future of neuroscience, and what are we doing about dementia, and how, by the way, can I avoid that myself? We thought about that when we were working with chocolate. And along the way, I discovered the microbiome, which made me think about myself in a completely different way. The idea that I have more bacteria in me than Jane DNA was kind of a profound and shocking thing to realize. And it came at a time when my hormones were changing. And all of a sudden I realized, I am not this static thing anymore. I'm kind of this amorphous thing, and I'm shifting with what I eat and the bacteria that I'm surrounded by, the hormones that I'm, producing or ingesting, as the case may be. And all of a sudden, everything just seemed a lot more fluid. And so I began to go to medical conferences and read books, and all of a sudden I thought, damn, these are the smartest people in the world. These MD, PhDs, who are deep, deep, deep into neuroscience or genetics or microbiology or whatever it may be, and we expect them to be hackers now. And so I just began to realize that not only is it changing the way I think about my body and my longevity and my family, but it's how do you think about fertility? How do you think about exercise? How do you think about what you eat? And I began to realize that this was all happening, that Silicon Valley was going to throw stupid amounts of money at this, and that there would be a whole new profusion of innovation that could take us into places that people could hardly imagine, and no one was imagining it. And I realized, as a former publisher, I'd been out of the media business for a very long time, and I began to realize that there was actually no place to go where you could get all that information and get that context and get that perspective other than science fiction. And you know, there's like the science journal, there's science fiction, but there's the science journals, which are very vertical, which is what would happen when I would go to these conferences. You know, there'd be these people who are so deep in this that everything that came out of my mouth was a complete shocker to them because they were not able to piece the pieces together and see how it all would play out. There were and are business publications, and it's all about, you know, who's investing in what and what categories are hot. But again, there's no context around that. You know, or there's the general media, which is, you know, really titillated by the stuff that people like Josiah do, but still lacking context and lacking, you know, sort of grounding in the underlying science and technology. So I decided to go back to media, and I launched this publication with Simone's help a little bit. So it's nice to see him. And it's called Neo.Life, and that's using .life as a domain name, because that's cooler than .com. And so we are putting together stories that cross over all of these disciplines and that try and paint a picture of where we're heading. And that picture, very much like back in the Wire days, is about a de-evolution of power and information from, you know, hospitals and pharmaceutical companies and doctors into the hands of patients and hackers and hobbyists. It's about, you know, our cultural response to that. What are the science fiction writers, you know, writing about? What are our television programs and movies about? What are our visions of the future? I mean, we are alive right now at a time when we can edit the human germline. And so we will change our species faster in the next 5 years than it has probably changed in the last ever. So the rate of acceleration of evolution is what we're dealing with here. But it's also this specific moment in time when we're trying to figure out what CRISPR means, when we can use it, when we can't. And then what happens when you put regulations in place that everyone in China is ignoring anyway. And so there's just all these big technical questions, scientific questions, regulatory questions, cultural issues. And I just wanted to be the place where all that could start to play out. So that's what I think about.
No, that's awesome. Yeah, no, I think you said some really interesting things, and that's one thing maybe I'm interested in. Maybe, you know, I didn't plan on doing this at all, but I think it would be a brilliant question because, you know, some of you, though you don't look like it, lived through the time when computers went from the size of a room to like a personal computer. And now with biology stuff, we see a lot of debates about like the ethics of everything, right? It's like, is it ethical to do this? Is it ethical to do that? And that seems like a lot of what's going on. And one question, this is just personal, and sorry, everybody, this is just personal. Like, what was going on then? Were people arguing about this stuff with computers? Were people like, is it ethical to give people personal computers? Or is it ethical to like use computers? Or no, not at all. Were people just like, let's just do this stuff and get it over with?
Yeah.
Yeah?
Look up computer professionals for social responsibility.
Oh, yeah.
Well, the big problem,
Which was founded at least 35 years ago.
well, the big problem back then was the fact that it was just difficult enough to get anything to work. No, I mean, seriously, I mean, everybody was programming the assembly language. Higher level actors were careful. Well, yeah, and they're still arguing about Fortran and a bunch of other things like that. So that was the problem.
Yeah.
You know, it's like, you want to deal with security, it was hard enough just to get a network to work.
Which I think is now the problem with biology. It's very hard to get anything to work.
That's kind of our argument when people are like, it's dangerous, and you're like, oh, well, you know, it's really hard to do anything right now.
But maybe that's exactly how people were built in the 70s. Just to comment on the sort of parallel with the history of computers. So I recently read a great book called What the Dormouse Said by John Markov. So I have no firsthand experience of any of these things, but what was really fascinating about the sort of story of Silicon Valley is how closely the development of technology was enmeshed with sort of social and cultural and ideological issues. How all the same counterculture people doing LSD experiments, being part of the sort of anti-war movement, etc., were also the people at sort of SRI and Doug Engelbart's lab, sort of developing windowed interfaces and the first mouse and all that. And I forget now the sort of name of the founder of the Homebrew Computer Club, who got his initial grant from Stuart Brand, who was a very active sort of member of the sort of anti-war movement, who wanted who actually wanted a computer to organize his social network of like-minded people instead of using sort of file cards and things like that. So that sort of computer as a tool for decentralized organization or as a sort of a tool for bringing people together was kind of baked in from the start, and I think some of that ethos still survives. And it's actually not completely clear to me, and maybe it's hard to see it because it's happening right now, what the sort of ideological and political sentiments behind biohacking are. I mean, what sort of are there similar trends sort of pushing us to do crazy things with cells and DNA?
Well, there was that famous debate between Steve Wozniak and Steve Jobs over whether or not you should be able to open up the box and hack your own Mac, right?
Yep.
I don't know, was the Berkeley Mac user group violently split down the middle, or were they
No, they
all
were
on
just fanboys from the beginning.
whatever? Yeah. So on Steve's side, on Jobs' side, or
Which Steve, depending on the day of the week, as far as I could tell.
yeah. But that's kind of where we are
Yeah.
right now. Is everybody is very excited that the people in charge, the sort of the hospitals and the doctors and the National Institutes of Health and all of the FDA, we're very excited about the things that they want to do. But there's this other thing that's just bursting at the seams, that's just exploding, of people who want their ear to fluoresce.
That's what I'm interested in right now, and maybe y'all could, something we could talk about is like what's going on right now, right? For me, it's the whole biohacker thing. That like envelops my life. Hobbyists who are starting to get this technology and use it, right? And they're just doing whatever they want with it. Screw regulations and ethics and everything like that. That kind of envelops my life. But you all are from, completely different points of view. Jane, you kind of see everything. Hannu, right? You're running a business, and Moe, you're seeing all the businesses going on. So what's going on now besides, biohacking?
Yeah, I mean, in terms of gene editing, there's actually, I think a lot of people in the audience know about CRISPR and kind of the revolutionary technology it may end up becoming. It's still pretty early, but Josiah and I were just talking about this before the panel. Ton of public companies now that are working on getting to human trials. Now, like in China, you don't have that sort of regulatory barrier here. That sort of, I would argue the ethical considerations when it comes to gene editing are even greater than programming assembly or hacking into a Mac or whatever it may be, just because you're dealing with the human body and there's this sort of notion of playing God,
All right, Moe, you're in there. You're in it.
Yeah.
So what's the bigger fear, AI or hacking humans?
Ooh. Oh man, maybe using AI to do the biohacking. That's probably, we can't even do our own biohacking. The AIs are hacking us. No, it's. I think I disagree with Elon on this because I think he's made some statements about how worried he is about the proliferation of AI. I think that could happen theoretically in the future where if somehow AIs are able to reproduce in the wild and we can't just pull the plug or splash some water on them. It's a very crude analogy, but I think with biohacking in general, there's just this fear among, especially synthetic biology. The term almost had a very negative connotation. Just looking back, the last 10 years, even before CRISPR existed, and I think there's sort of this public education piece that has to be part of it to educate people of the benefits of using these as therapies, right? If you can correct a single gene mutation for somebody who has a sickle cell anemia, that could change their life, right? And if you have a cure, that would be enormous. And so there's a lot of work going into this now. Companies, academics. China, I'd argue, is a little ahead just because they don't have the regulatory barrier. But there are, I think, real therapies that we're going to see developed over the next 5 to 10 years that are going to save people's lives because of things like gene editing.
I got another question. The Morris worm, did that set things back? Or no? Were people just like, no?
So can you repeat the question? Sorry.
The Morris worm, Robert Morris, he wrote this worm that went and spread and crashed a bunch of computers, used like finger and all this other stuff. It didn't set like computers back or anything, like people weren't more scared of computer systems or anything. That's for sure. Because I mean, I think about, what you're saying, I think about like, it's true that a lot of these things can't spread in a digital world, and biohackers, it can spread if something bad happens. Will it set things back? I don't know. I don't know. But what do you see, Hannu, going on?
Well, I mean, so I'll sort of first wear the sort of biotech startup founder hat, and then I'll put on the crazy hat. So just even if we sort of restrict ourselves to mainstream biotech, it is an extraordinary time. I mean, we just had literally this year the first FDA-approved gene therapy, which was sort of Spark Therapeutics is viral gene therapy for sort of a rare eye condition, and then we have also Novartis's.
You know what I found crazy about that, right? Like the Luxturna, which costs what?
$850,000 per eye, I think,
or something like that.
Yeah.
You can go and you could order have a custom order a virus that replaces, I forget, it's some retinol, gene in the eye for like $3,000. If you just went to a company and knew the gene, pretty interesting.
I mean, it might be still a little bit more expensive for sort of clinical grade.
Yeah. But I mean,
still,
you're talking.
I agree. I mean, so it is true that sort of these new therapies do come with enormous price tags. I mean, that's why they are sort of targeting these very rare, debilitating diseases or cancer. But they are getting FDA approval, and these are sort of very extreme therapies where you infect the patient with this virus that delivers genetic payload into the eye, or in the case of Kymria, you actually take the patient's T cells out, you genetically engineer them, and then you put them back in to go after sort of the blood cancer. I mean, these are quite extreme biohacking feats. I mean, they're sort of, and FDA is now willing to sort of go with these. So I think we will see a lot more coming through that pipeline, and then the question becomes, can we afford to pay for them? What is actually the model for regulating some of the even more innovative therapies where you can take an individual patient's tumor and sequence it and then tailor a therapy for that particular patient? How do you sort of take that through clinical trials?
And that's like an interesting relation to like software and copyright, because when software came out and people couldn't afford it or they didn't want to afford it, right? They either broke the copyright and copied it and shared it with their friends or something like that. You think a similar thing will happen with biologics? Like people will be able to reverse engineer them and make them for really inexpensively?
Yes, quite possibly. I mean, I think the problem with so I think that's actually not to sort of blow the HelixNano trumpet, but I think one of the but I will. I mean, one of the since you asked. So right now we have to make biologics in these very big production facilities with sort of tens of thousands of liters of Chinese hamster ovarian cells genetically engineered to produce your sort of cancer drug or sort of enzyme replacement or whatever it is that then sort of get harvested and purified. But what if you could get sort of $100, $10 worth of DNA, inject that into your own body and have your body produce the biologic? Now, right now we can't do that because there are sort of limitations to the efficiency of how much DNA you can get into the cells, and that's basically what we're working on. But yeah, I think things could get really crazy. I mean, we could see sort of
because $850,000 is a lot of money, right?
Okay, but then there's this whole range of options between the sort of radical stuff that you're talking about and the other stuff that happened in the last 12 months, which is like, digital therapeutics, right? So we got the first digital pill, and we got the first digital approval from the FDA for online therapeutics for mental illness and addiction, right? So there's this vast array. So lest we paint a picture of this as being completely out there still.
What's a
So-
digital pill?
So the digital pill is something that you swallow, and it goes into your stomach, and the amount of stomach acid that it registers, I forget the details of it, but it's a company called Therapeutics. No, it's
Proteus?
Proteus.
Proteus
Yes, but they sold it to, or there's a company that's using it, it's commercialized it. It's Proteus's technology, and it picks up stomach acid, and that's how it knows what to release.
The idea is to track it and make sure that you're actually taking the pill.
Exactly.
Not just a gateway.
So it's for compliance. Yeah.
Yeah, so I guess there is that sort of whole other side of how does sort of our generally our information technology and also our sort of generally better understanding of biology feed into like the microbiome sort of connection between the nervous system and inflammatory response. How does that sort of enable new kinds of therapeutics? There's a company called Link who sort of started out as a sort of an electrotherapeutic or actually they started as cognitive enhancement. They sort of tried to have sort of direct current brain stimulation to enhance performance. And what some of their patients, some of their test subjects ended up finding was that their psoriasis got better.
Mm-hmm.
And now they're sort of psoriasis. Sorry, my Finnishness sometimes comes through. I used to pronounce rhinoceros for a long time as rhinoceros. Anyway, but the point is that this is sort of another interesting example of that sort of there's new biological insights that allow them to understand what's actually happening, and then they have this new sort of cheap technology delivery platform that it looks very different from some of your traditional drug or pill or injection. So. But to kind of get more into the scary stuff, I mean, I think sort of as our powers grow, I mean, one interesting example
Is this your sci-fi hat on now?
not kind of getting there. I mean, one interesting example are.
What do investors think? Putting money in the hands of a sci-fi writer. What
Well,
could possibly go
what
wrong?
could go wrong? I guess one sort of scary corollary of CRISPR is sort of the ability to manipulate entire ecosystems through things like gene drives. So gene drive is essentially an application of CRISPR, another genome editing tool where you sort of put a foreign gene into a population, and then the system ensures that every descendant of every organism gets that gene. So it sort of spreads through the population like wildfire. And people are applying to these things like actually sort of making malaria, spreading mosquitoes infertile and things like that, and there are already field trials. So I think that the sort of scary thing about biology is that we can never sort of fully control it. Like we have to set up these elaborate frameworks in the clinical context to try to control it. And I think that's one reason why in sci-fi, biology has always been evil. It's always there's I think I think Isaac Asimov even coined the term the Frankenstein complex. I mean, the first instance of biology in sci-fi is Frankenstein, and
By
it's
the
sort
way,
of
it's 200 years this month since the
yes,
publication.
that's right. That's right. And it's actually a very remarkable book. I mean, one of my favorite quick digressions into that. It's not that actually the Frankenstein's monster is quite a wonderful creature. It's a superhuman being. I mean, it's sort of smarter and stronger and so on. It's ugly, but sort of it's essentially superhuman. And what sort of drives it into this destructive behavior is not some inherent evil, but the fact that. But sort of the fact that Victor Frankenstein rejects it. He sort of abhors his own creation and refuses to take responsibility, and that's what sort of drives the monster to do harm. And I think that's a very good lesson, which most people kind of tend to miss when looking at the movie or media versions. But anyway, I mean, I think we do have a lot to do, and hopefully people like Jane and can also sort of contribute to that through your channels to actually kind of rebrand biology and create better narratives.
Does it need rebranding, Jane?
Yeah, I think so. I mean, synthetic biology, when you start talking about food, people will not respond well to synthetic biology.
It's really weird, right? Because I see people who like support human genetic engineering but are against like food genetic modification.
Correct.
And you're like,
I know, and when you
strange.
start to say, but if we produced cellular agriculture, if we produced, meatless meat, animal-free meat, wouldn't that be better? Look how much water you would save. Look how much, gas you wouldn't be releasing to the atmosphere. Look how much land could be returned to, natural state or whatever. But it's like these are chasms that they're unwilling to cross because they don't understand biology.
Yeah,
Now,
but
most
compare that to the stuff that's on the grocery store shelves already.
Well, exactly.
I think it comes down to marketing. I mean, we're an investor in Memphis Meats. It's a company that is actually isolating stem cells from cattle, from ducks, from chickens, what have you. It's multimodal in terms of animals, and they're actually growing meat in a petri dish. And they have a consumer product that they're working on now, and they've actually done trials with consumers where they've given them real meat and the Memphis meats, which is real meat. It's not, it's literally from animal cells, and people love it. People love it. So I think getting the marketing right is going to be vastly important. But once you abstract away some of that, the underlying biology, the petri dish, what have you, ultimately people want a great product, regardless of its technology or biotechnology. And that's where they've seen some success, but it's super important, and getting the story right is going to be really important too.
Yeah.
But what about misuse? I mean, we have biowarfare, so
Totally.
unfortunately.
Well, hopefully that's where regulation comes in. I mean, regulation is good and bad, right?
That's what they're going to, I'm predicting right now, 2050 election, Russians hacked the president.
Literally hacked the president.
Literally hacked the president.
All it takes is for somebody to take one glass out of the Mar-a-Lago, table
That's right.
that he's sitting at, which how hard could that be? And the next thing you know, we've sequenced his genome. Now we can target something specifically to him that, I don't know, makes him crazy or something.
Yeah. No, it's true. I mean, we've been talking a lot about just therapeutics and writing DNA, but just even reading DNA, just the innovations that have happened there. I mean, the cost of sequencing, it was $3 billion to sequence a human genome. Now companies can do whole genome sequence for less than $1,000, and that continues to go down.
These are. If anybody is interested, you're data geeks, so you get a lot of data. This is a company called Veritas Genetics.
Oh, yeah.
$1,000. They will give you
Good guys.
the whole genome sequencing, so you can take a card.
Really?
Yes.
What do I do with it?
What's that?
What do I do with the genome?
Well, you have to find a physician or a genetic counselor that can help you, put stuff into context. And they won't give it to you
But if
unless
you
you
just
have a physician who writes
If you
it.
just want to play around, so right now it's really the interesting thing about all this data that's been collected. So they've sequenced thousands of genomes of thousands, of tons of organisms, and they've stored all this data online. So there's online repositories of this. A lot of studies that have been done trying to associate different genes with different diseases or different mutations in different genes for different diseases. So there are actually websites out there that are free to use where you can upload, sequences that you get, and they'll analyze it for you and give you predictions based on data out there. So that's stuff that you can possibly do.
You can take your 23andMe data and upload it to a site called Prometheus, and they will start to parse it for you.
So I actually had my full genome sequenced through, Illumina has this event that they'll do. They'll sequence your genome, pair you up with a physician, and you actually get a clinical report that then he walks me through. And I actually had something that was clinically pathogenic. So MC4R is the gene that I have a mutation in, and it predisposes me to obesity. So I guess I have some fatties in my family, and so as and knowing that, exactly. That's basically what he said. But in terms of a lifestyle change now, I know that I have to be careful about what I eat, how I exercise, because I'm genetically predisposed to obesity. So I have to think about that, and I think that information is super powerful going forward, and it causes me to make lifestyle changes because I know that, hey, there's something that I have to compete against when it comes to nature, but I can do that. Just it's not DNA in itself, right? You can make changes in your lifestyle to kind of account for those sort of things, and that's why it was super useful for me.
So one of most companies is Human Longevity Inc., which is Craig Venter's company, and Craig was the first person to sequence his genome, his personal genome. And until this month, actually, for $25,000, you can go and get this full body scan, full body MRI, right? You get your whole genome sequenced, you get all this other metabolic information. They would just give you like the ultra leading edge executive,
Yeah.
workup. They've just lowered the price to $5,000. And so you get, the whole genome sequencing, which these guys will do for $1,000, plus you get a whole bunch of additional information that can spot. And they're finding up to 30 to 40% of the people who come in have some kind of clinically relevant finding. So they may find a tumor. 5% of the people find tumors that they were unaware of. They're finding a lot of precancerous cells that could become cancerous cells, so like stage 0. Craig is convinced that this is how we're going to get an extra 50 years added to our average lifespan, is by just simply identifying the things that would otherwise kill us as we age, like cancer and heart disease and things like that. The naysayers will tell you that the incidence of incidentaloma, which is the cancer that wouldn't actually ever develop. You may have those cells, you may have that predisposition, but unless you made significant changes in your lifestyle, it would probably never develop. But now you know about it, so you're going to do something about it, in theory. But this is the power of data, and these are the things that people have to grapple with. You find out you have the BRCA1 gene, and your mother and your grandmother have had breast cancer. Are you going to have a prophylactic mastectomy? I mean, these are the decisions people are making.
So what does the AMA say about these things? I mean, about the efficacy of these things?
Well, this is why 23andMe was shut down. It's because they did not want to give this information to people without the benefit of genetic counsel. But this is the same thing the FDA said about at-home pregnancy tests. That women would be throwing themselves off of bridges when they found out that they were pregnant. It's like, didn't happen.
There's a popular song about that. And at some point we're going to get into the social thing.
Right.
Yeah, no, I find that really interesting about the whole biology and biohacking, is that computers allowed us to change our world and have access to all these things that affect us, like digitally. Like, we can communicate with people, we can, take care of our finances and bank account and put media and everything out there for everybody to see.
And get spied upon.
But we can't affect us, right? It doesn't I can't use.
But we have.
No.
Facebook has made us miserable.
No, I understand.
The wrong people.
I understand that, but I mean, now what I'm seeing with this whole, people getting into biology and medicine, you're talking about, what happens if instead of $5,000, I could walk down the street, go to a free clinic, run the test myself, or run it for free, and you could check yourself all the time? How would that change the things we do? What happens if I could write my own prescriptions for myself for harmful medications, right? How would that change?
Well, America requires a lot more prescriptions for medicines that are available over the counter in other countries.
Oh yeah.
You just need to cross the border down to Tijuana.
Yeah.
You could buy Cipro for any antibiotics. You could buy Viagra.
Cialis from Canada.
True biohackers hack themselves.
Yeah, they do. It's a big thing that's actually going on right now because it's really interesting, right? So in order to do experiments on humans, you have to go through a huge process with the FDA, right? You usually have committees, and for a good thing, right? Usually you're trying to create a drug or medication that treats the most amount of people with harming the least amount of people, right? So, and also make your company money. So you want it to be really well tested. Well, the problem with that is that you can't test more things that are more breakthrough or just starting to come about, or things that are a little bit more risky. But if you test something on yourself, it's okay, because the FDA needs kind of like a plaintiff in order to do something, and you're probably not going to press charges against yourself if you hurt yourself, right? So
Maybe do it.
Actually, the new tools that are available now allow you to use mouse models and things that you never could use before, because old biohackers, 20 years ago, always hacked themselves.
Yeah, no, I mean, and it's happening more and more now. People are trying to engineer themselves. There have been a number of cases in the past, 6 months where people are, engineering some DNA and injecting themselves with it, putting it in their cells and seeing what happens. A number of cases where people are doing this, and it's only happening more and more. I know
How many of those went sour?
none.
None so far?
Yeah, well, I mean,
Pretty lucky then.
well, so
you could
it's,
screw up there.
no, you can't. Well, here's the interesting thing is that we don't know enough to hurt ourselves too much.
Most of it doesn't work yet.
Yeah, it's like, you know, if you're trying to do something where you're affecting some metabolic thing, it can get a lot more complicated. But a lot of people are interested in pretty basic stuff, changing something that's, you know, like the color of your skin or something, or like the amount of muscle you have, or something that's like really a lot harder for it to go wrong. But I imagine something bad is going to happen for sure. And that's an interesting thing, like how will it affect things? Will there be more regulation, less? You know, from other things that have gone bad in computers, it seems like, I don't know. Doesn't seem
And
like,
will we be able to attribute it to the action that you took?
yeah,
That's the other thing. You know, establishing causality is not easy.
yeah.
Well, I think we've had 20 years ago, 17 years ago at least, we've had some stage 4 cancer cures. They never saw the light of day because of, not because of FDA regulation or anything like that, just because the pharmaceutical market doesn't support it.
Totally. No, I mean, in the early days of gene therapy, they cured leukemia a lot. I think there were like 10 patients or something in a trial that they cured. One ended up getting, I forget what it was, maybe cancer, but then they did radiation and they cured that person. One person ended up dying, but yeah, this technology has been around since the 80s or 90s. To me, I think it's accessibility. I don't know. When I see like computer, so I grew up, you know, in the 90s, kind of like computer hacker, BBS, internet was starting to go around. Accessibility is what kind of made it for me, right? The accessibility of knowledge about how to program. You know, I read RFCs and other stuff, and open source software and stuff like that came from it. I wrote code and put it out there. But right now, it seems like the accessibility of this stuff is not there. And I'm wondering if that is what's holding it back, maybe.
When I started, the computers were within the financial ranges only of governmental entities, and they were serviced by high priests. 20 years later, the Homebrew Computer Club had reached it because the cost had dropped down to make that practical. 15 years after that, Morris put out the first internet worm. And 15 years after that, you have script kiddies. Am I the only one who finds script kiddies with biolabs absolutely terrifying?
So, you know, to answer your question about the Morris worm, since I have first-hand experience with that, oh no, seriously, it only ran on Vaxxon and Sun workstations. And the majority of people with PCs never would have seen the thing. We didn't get hits. We only had, where I work, we only had 4 Vaxxon and a small number of Suns. We mostly had SGI machines and Crays. And the thing is, most people don't, even to this day, don't know how to program for a Cray. And no, seriously, the reason is the fact that most people don't realize that not all computers, you know, an addition on one computer is not the same thing as an addition on another. People don't even realize word sizes and character sets even different, stuff like that. Now, as DNA goes, pretty much all living things go with DNA. We've yet to find a case for second genesis, as Chris McKay would say, for something using other than DNA. Now, there's really sci-fi writers. Let me tell you, my favorite episode of the original Star Trek was the episode with the Horta, since it was silicon-based. And you know, that brings up all kinds of other things. But we do now have far less architectural diversity as we've had in the past. And it is really largely ignorance that kind of protects most people from having more serious things happen to them. And I mean, you know, what most people don't realize is the people who really do develop weapons in the way of software, you're not going to hear most of them because they're professionals. And they're not like script kiddies like I was talking about. You know, there's actually there's been a professional society for several decades of electronic warfare people. And they number 30,000 members. These are the ones who are above board that most people are not aware of. And it turns out they had a meeting here at Stanford once that We were intending. No, it had to do with, the big frontier actually is unmanned aerial vehicles, autonomous cars. And it turns out 6,000 members live in the Bay Area, and most people have never heard of these people. Now I had to tell Dorothy and Peter Denning, like, why aren't you a member of the Association of Old Crows? And they go, what?
Crows.org.
Yeah, well, not just Crows, it's AOC.org as well too. But no, they have professional meetings. There's thousands of these people who do it professionally, and they do it to both offensively and defensively people. But keep talking about biology because they're not thinking about, those guys aren't thinking about biology.
So the FBI does consider the fact that we are shipping so much of our genomic data to China, where they're sequencing it faster and cheaper than most companies in the United States will. They consider this a threat to U.S. national interests.
I can't talk too much about that.
So I think people are sort of actively trying to take countermeasures against sort of genomic copyright theft. I mean, I believe that a lot of the biologics manufacturing organisms, the sort of Chinese hamster ovarian cells I was talking about, actually have sort of DNA watermarks effectively embedded in the genome that can be then later sequenced if somebody tries to create a strain sort of derived from that organism that has been stolen from sort of US facility. So people are sort of at least trying to come up with some ways of tracking and sort of controlling that. But then how do you actually fight back if somebody steals your organism? I mean, are you going to go to every biologics factory in China and take a sample?
No, it's
Or are they going to weaponize it somehow?
I'm worried about somebody altering the code protein of influenza and breaks the test tube,
I mean, I guess to sort of address the elephant in the room, I mean, there are, of course, great risks with bioterrorism. I mean, they're sort of, in parallel to the sort of development of electronic warfare.
Maybe, I don't know, not to interrupt you real quick, this is what I think about a little bit, is that like, all right, in modern times, so evolution has had a fair amount of time to evolve things to harm humans. What's the worst thing you could think of in modern times? So post-Spanish flu 1918, right? Like what's the worst? I mean, cancer probably, but it's caused by a large number of things. But like virus, bacteria, we have modern sanitation. It's really hard to spread these things, right?
Well,
like
smallpox. I had lunch with Larry Brilliant yesterday. So Larry was, part of the effort that eradicated the smallpox vaccine. And yet, people are synthetically engineering, horsepox in labs to see if they can use that for research purposes to create other vaccines. But how easy would it be for that?
Yeah, how easy is it to spread, right? And like, how would it spread? And
pneumonic plague in the horse period, when things moved at 3 miles an hour, killed half the population. Now, how long does it take to kill half the population when things are moving at 500 miles an hour?
And how long does it take to grow those vaccines, right? I mean, we have synthetic vaccines, but synthetic biology hasn't scaled yet. There's the manufacturing capability.
We need more biohackers so that we can do it.
Well, the point I was trying to make is that I think it's, again, one of those things where it's like we don't know enough to create something that would be harmful enough. Like, obviously, if I wanted to hurt somebody right now.
Since you're doing it deliberately.
Oh, accident is even harder. Because biological systems are so complex, so it's like, I want to create some toxin.
Funny, influenza does it every year.
You're saying it's complex, but I think trying to understand viruses and simple bacteria are a lot easier to hack than organisms and humans.
Also, the law of unexpected consequences is very powerful at the bleeding edge of any technology.
That's true. That is true.
What definition of harm are we using? Because as everybody knows, the internet is used for exactly 3 things. Cat videos. Arguing with people you never met. And I found it was interesting that I've been waiting for John Wayne to appear in movies he never appeared in. And thanks to Carrie Fisher dying, there's going to be that. But if you read your Slashdot today, number 3 on the internet got there first.
Deep fakes.
Replacing faces. So people who never appeared in certain sorts of movies are appearing in them now. It's script kiddiness already. So before Hollywood gets there, it's already happened. The third leg of what happens on the internet.
So you think people will get there fast? Hackers will get there faster than?
Oh, well, I was just measuring harm in terms of number of hours wasted in lifetimes. Cat videos.
I guess actually, from the sort of science fiction writer's perspective, I mean, we can sort of go back to the sort of bio warfare horror scenarios. But so I am writing a new novel on featuring sort of near future biohacking, and one of the sort of aspects I'm really interested in is future biocrime, not involving sort of ending the world through a disease that kills us all, but something akin to what you were describing. So sort of this malicious but sort of non-world destroying, slightly disturbing type of biohacking or biocrime that sort of inconvenience us and perhaps disgusts us, but doesn't sort of necessarily
Example.
kill us. Yeah.
Example.
So I guess the sort of thing I'm thinking about is unleashing some sort of fungal species that spreads into buildings and causes a bad smell. So sort of, or sort of, you were sort of referring to hacking the U.S. president, biological ransomware, where you sort of end up having to take a drug that only the sort of biohacker can provide, or you get sort of annoying or lethal side effects. Etc.
Or simply creating something like that and then investing in a company that has the cure, for example.
But I think there's sort of, but I think the history does kind of show, certainly with computers, that the street finds its own uses for things. Like weird things will happen. My favorite bits of news recently was. Botox injections are now forbidden in camel beauty contests. So they are. It's been so common to sort of modify camel appearance with Botox in beauty competitions. But it's now forbidden. So imagine when those people get their hands on more sort of advanced bioengineering tools. So I think the future will sort of be weirder and more human and kind of more disturbing on some level than we can possibly imagine. I mean, on the sort of bioterror threat side of things, I mean, it is harder probably to engineer pathogens that you would sort of instantly think, but doesn't mean it's not possible, and we might see outbreaks of bioweapons in the future, but I guess the sort of only comforting thought there is that our countermeasures will also continue to get better. You were sort of commenting on vaccines. I mean, DARPA does have a big program running, called Adept Protect, where the idea is that you can just sequence a new virus in the field using a portable DNA sequencer, send the DNA code to a remote lab that can then engineer a very potent antibody against it, which you can then put into synthetic DNA and quickly ship.
Soon you have a perfect vaccine in infinite quantity in 24 hours. How long does it take to get distributed in Puerto Rico?
So DARPA's challenge is 30 days. 30 days is their goal.
But you'll have the people who refuse the shot. You'll have the people who are running away. This is a social distribution problem. This isn't a medical problem.
It's true.
No, that's true. But I mean, and I guess we'll have to tackle it at all those levels. But here we've sort of been mostly focusing on technology. And but you're absolutely right. I mean, with any finding a solution to any problem, it's the human element, political element, social element, economic element that also comes into play. And I guess it's very hard to foresee how the sort of widespread availability of various biohacking tools will play with those elements.
All right.
So one thing is easy to foresee: a whole lot of dead people.
So if I want to make a vaccine and I have all the recipe, how big a factory does it take?
Does it fit in a shipping container? Or,
You can. So DARPA has designed these units that do fit in basically shipping containers, which can manufacture a lot of. Sorry.
What sort of raw materials does?
So you need so for
DNA and cells and stuff to grow them. That's basically it.
Or the sort of purely chemical methods where you basically need some enzymes and sort of a water vat that can be heated and cooled, sort of a big PCR machine essentially. And then sort of the base nucleotides at least as sort of the starting point. So not an awful lot actually.
PCR at home is tabletop, that thing.
Yeah, but here I guess we are talking about things that can scale to thousands of or tens of thousands of human doses. So yeah, you would probably need something shipping container size for that.
So it's not off scale to consider, a factory that makes shipping containers and sprinkle them all around the world so that when the fan gets dirty, I can send an email and poof, they all start making stuff.
That's right. I mean, synthetic genomics had a...
Including to the moon and to Mars.
Yeah.
All right, we're going to finish up. You guys have any final things? Mo, I know you got something to say. I'm seeing it in your face.
No, outside of bioterrorism, I'd say, just the social ramifications of, something I'm cognizant of, technology creating this accelerating rich poor gap, right? And if in the future, if it's only, wealthy people that have access to some of these therapies and things like that, or if we start to be able to engineer the human race, but it's only wealthy people that can do it, that completely creates this larger chasm that what we're already experiencing, even in the United States, right? If you look at the election and some of the ramifications of that, the consequences of that, and things that were even happening before that, and then also just loss of privacy I worry about too. If you're leaving your DNA everywhere and it's cheap enough to be sequenced with a handheld device, then anyone can track you anywhere you go. I mean, it's already happening in the digital sphere now with being online. And then also just cameras, computer vision being ubiquitous. But if it's also DNA, you start to really, the end of privacy could be real. So those are some of the, outside of terrorism, which is, I think always a concern, but relatively low risk, at least now, just things about our day-to-day and social interactions that can change.
All right. Thanks for having us. And if you have any questions, you can hang out and ask them to us. But I appreciate it, everybody, for listening to us ramble about crazy stuff.